Another induction question that I found. I'm going to ask you to consider a function defined by this. So a function for n depends upon the previous function. So a recursive definition of a function. So to start this going, I have to give you the value of f of 1. So if f of 1 is 1, you can then use this relationship to find out f of 2, and then f of 3, and then f of 4. Once you've got those, you can predict what you think is the result for f of n. So I'll leave you to work those out and conjecture a result. I'll leave you to do that now. If you did that and did that correctly, then you'll find that you think the formula is n squared. But unless you can try all of the integers, which of course is impossible, you can't prove that. So we're now going to prove this by induction. So proof by induction. And of course we're going to start off, as always, with our basis step. So let's go. Basis step. I want to show that this result is true for n is 1. If n is 1, then f of 1 is equal to 1 squared, which is equal to 1, which is correct, because that was given earlier on. So therefore, the result is true when n is 1, and the basis step is done. So I move on to the inductive step. And as always, I'm going to start off by making the assumption. Assume the result is true when n is equal to k. And I'm going to write down what that means, i.e. f of k, remember this is the result we're trying to prove, the f of n is n squared 1, so I'm going to assume that f of k is equal to k squared. Then I want to show that the result's true for the next one up. So I'm now going to aim to show the result follows for n is k plus 1, i.e. I'm going to try to show that f of k plus 1 is equal to k plus 1 squared. And if I can do that, then I'm done. So how am I going to do this? And our left hand side is equal to the f of k plus 1. Now I think, how am I going to proceed? Well, this is where I'm going to use the definition that was given at the top. F of k plus 1 I can work out in terms of f of k using that relationship there. So f of k plus 1 is going to be f of k plus 2 lots square root f of k plus 1. Now of course, by my assumption, I know that f of k is equal to k squared. So this is where I use my assumption. F of k is k squared plus 2 lots of square root of k squared plus 1, k squared plus 2k plus 1. Of course, that factors very nicely to be k plus 1 squared, which is equal to the right-hand side as required. So I've completed the inductive step. Of course, I've not finished. I need to conclude. Hence, by mathematical induction, the result is true for n is 1, 2, 3, or for all n belonging to positive integers.